Hello, I'm Illustrious Illustration. I'm a chemistry graduate, and now I would like to try again explaining Dr. Stone parts with the chemistry knowledge that I have. Senku and Ryusui decided to find wheat to not only help with Ishigami villages and Kingdom of Science food supply, but also to supply their future ship with food. The exploration team found it soon enough, and now the Kingdom of Science can start farming properly on Kanto Plains. It's now up to the muscle heads there to labor as hard as they can to supply the kingdom with plenty of food, and earn bragging rights as king of food. Thanks again. Out of all the muscle heads, Taiju blows the competition out of the water, partly because of his limitless stamina and endurance, and partly because he remembered Senku's lecture from way back in episode 2 about calcium carbonate in agriculture. Taiju's field shows that his soil turns the Morning Glory paper violet, while for everyone else's field, the paper turns red. The topic I want to focus on is about the last two sentences, fact-checking soil pH for wheat, fact-checking the flour used, and talking about how pH changes the color of the flour paper. First, let's do some fact-checking first. From what I find, wheat grows in pH range of 6 to 7, with the most optimum pH being 6.4. Not exactly alkaline, because by definition in chemistry, alkaline means pH above 7, but pretty close to neutral. For the flower, there are literally over 1000 species called Morning Glory, but my guess is the one mentioned in the manga is Ipomea nil, also known as Japanese Morning Glory. I'll be explaining interchangeably using another Ipomea flower though, using Ipomea tricolor, Mexican Morning Glory, especially the heavenly blue cultivar. In these flowers, the chemical responsible for the color are the derivatives of pyonidine, and pyonidine itself is one member of a class of molecules named anthocyanidins. I assume that regular pyonidine and derivatives of pyonidine have similar color change in different pH, because they are both anthocyanidins. For pyonidine, the color is red at pH equal to 2, and then turning to purple, then to blue at pH equal to 8. Now, I'm guessing that you guys lost me at the second half of that paragraph just now. What the heck are those pyonidine or anthocyanidins? They are all pH indicators, so I'll explain from the simpler non-anthocyanidin indicator. A pH indicator chemically can be seen as a weak acid, whose protonated form and deprotonated form have different colors. I'll use phenolphthalein as an example of pH indicator because it's popular for several reasons. And weak acids are acids that don't dissociate completely, for example acetic acid. Due to Le Chatelier's rule about equilibrium, when the solution has low pH, aka high H+ concentration, the equilibrium is pushed to the protonated form. Because the protonated form dominates, the solution is colorless. The opposite is true when the solution has high pH, aka low H+ concentration. Now the deprotonated form dominates, and the solution is fuchsia pink. With anthocyanidins, the system is slightly more complicated. Now we have 3 equilibrium reactions, and a total of 4 forms, which have charges of +1, neutral, -1, and -2. Of course, each form has different color. The structures and colors listed on the left are for cyanidin. Anthocyanidins are not special to these flowers. They and its derivative anthocyanin, which are the anthocyanidin sweet sugars, are responsible to the red or purple or blue or black color of many plants, like grapes, roses, purple cabbages, and radishes. Oh, by the way, this is not litmus paper, because the dye or the indicator you get from lichen is a bit different. I guess you can say that this is Morning Glory paper. Also, in Chrome's Jailbreak, back in Season 2 Episode 6, the fake pneumonia blood from seesaw and acid is also using the same pH indicator principle. The chemical that acts as pH indicator is seasonin, which is an anthocyanin, and it is reddish pink in acidic condition and brown in neutral condition. In conclusion, Paiju's wheat grows well because he made sure his soil pH is alkaline. It was checked using indicator made of Ipomea flowers, which has anthocyanidins. Anthocyanidins and other pH indicators change color as they change forms and follow the rules of chemical equilibrium. Anthocyanidins can be found in all sorts of plant parts. That's all I have for now. If you have questions on the part that I haven't explained clearly, do not hesitate to comment your questions below. Like the video if you are satisfied already, and subscribe if you want more videos like this from me. Thanks for watching.